So today we are going to discuss about the core topic of reasoning, distance, speed and time. So let's see. Before we are going to the problems, we will see what are the major equations to solve these kind of problems. So in case of distance, speed into time. In the case of speed, distance by time. In the case of time, distance by speed. So these are the basic equations when we are going to solve these kinds of problems. In all competitive examination, definitely there are problems for in distance, maybe in the case of time and speed. So in the case of distance, they are asking, we need to calculate distance by speed into time. So question clearly, you need to read the question clearly and we have to calculate speed into time, then we will get a distance. In the case of speed, we need to calculate distance divided by time, and in the case of time, we need to calculate distance divided by speed. So let's see what are the basic problems to solve when we are using this equation. So first problem, a boy walks at a speed of 4 km per hour. Just underline that 4 km per hour. How much time does he take to walk a distance of 20 km? So in this question, we have to clearly know a boy walks at a speed of 4 km per hour. So we will get the 4 km per hour, that means speed. And how much time does he take to walk a distance of 20 km? So we will get the distance also. So the question is how much time, so we need to calculate time. Above we have already mentioned what is the equation to calculate the time, distance divided by speed. So we will get, so we are using this formula to implement this one, 20 divided by 4, that means 5 hours. The boy need 5 hours to meet 20 km per hour. So this is a basic way to solve these equations when we are using these equations. So we will go for the next problem. So problem number 2. A cyclist covers a distance of 15 miles in 2 hours. Calculate his speed. So when we saw a question, first we need to underline what are the elements we have. So here mention the distance 15 miles and the hour is also here 2 hours. So we need to calculate speed. So we are putting in this to our equations, we need to calculate the speed of that particular cyclist. So here speed equal to distance divided by time. So here speed equal to 15 divided by 2. 2 is our time hours. So we will get 7.5 miles per hour. So we need to mention the 15 miles because the question is already mentioned 15 miles. So we need to put 7.5 miles per hour because we are we are calculating a speed. So this is a question to solve speed of a particular thing, like whatever it is with train or here cycle with, they are mentioning like cyclist. So we will go for next question. So next we are going to see, we are already discussed about the time and speed, then we are going to discuss about the distance. Problem number 3. A car takes 4 hours, just underline that, 4 hours to cover a distance if it travels at a speed of 40 minutes per hour. Here, like just to underline that 40 minutes per hour, what should be its speed to cover the same distance in 1.5 hours. Here already mentioned hours, 1.5 hours, so we need to calculate what is the distance. So distance, so we need to, here we have to mention distance covered equal to 4 into 40. Here 4 is already mentioned here, and what we have to calculate the speed of the particular car, like 40 minutes per hour, so we will get 160 miles. So this is we are putting the equation for speed into time, how much the speed and what is the time to get that particular distance. So we will get the distance covered 160 miles and speed required to cover the same distance. So here speed required to cover the same distance in 1.5 hours. So here we will already get the 160 miles. So 160 divided by 1.5. 1.5 is already mentioned here, the same speed, 1.5 hours. So we will get 106.66 minutes per hour. So this is the answer when we are going for the same speed required to cover the same distance in 1.5 hours. So these are the major 3 equations related to the problems. So we will already discuss about the time and with the problems of time, speed and distance. So next topic we are going to discuss is time and work. In this topic, before that we are going to solve the problems, we need to know, we need to analyze the basic concept of solving these kind of problems. We will see one by one. So first concept is complete job. The total amount of a complete job. That is 1. Like when the questions is clearly mentioned a specific time, then it will become that figure. But if the question is not mentioning any specified time or specific time, we need to assume that a complete job, a total amount of completing a particular job is 1 day, is always 1 day. This is a basic and a first concept of when we are solving the time and work category of problems. In the case of second concept, 1 day work. In this case, if a person A can do a work in a day, then A's 1 day's work will be So we need to know basic concept of this kind of problem and work related problems. So in this, one day will be calculated in, if a person, that means A, can do a work in n days, a number of days, that may be a 1 day, 2 day, or above 4 and 5 days, then A's 1 day's work will be, that means this n number of days at particular 1 day will be 1 by n. This is the second condition or concept of solving these problems. Part of work done, that means a partially completed work. If A's 1 day work is 1 by n, we are already seeing the second concept, second rule. After x days, A's work equal to x into 1 by n. This is the third rule. That means compared to the second rule. Part of work done, that means a partially completed work. If A's 1 day's work equal to 1 divided by n, we are already seeing the second rule. After x days, A's work equal to x into 1 by n. This is the third rule of calculating working time. So fourth rule, combined 1 day work. That means if one or more persons doing the same work. So how we have to calculate? What are the rules for calculating combined work? 1 day work. In this case, here already mentioned that more than one person are working on the same job and their combined 1 day's work. If A can do a job in n days and B can do it in m days, and both A and B, see A and B together can do it in T days, then the equation will be A's 1 day work equal to 1 divided by n. This is one person's A's only, and in case of B's, 1 day's work will be 1 divided by m. So in this combined one, that means A plus B, because the both persons are doing the same job in a one particular day. So we need to do the both persons working hours and work. Combined 1 day. One day's work equal to 1 divided by T. That means we are taking that concept 2 equal to A's 1 day work plus B's 1 day's work. That means the equation will be T equal to N into M divided by, not whole, divided by N plus M. This will be the equation for combined. This is the fourth rule of we are calculating working time and the days. So we will see the fifth rule of this kind of problems. Rule number 5, comparison of two workers' rights. So before that, rule number 4 we are discuss about the combined work rate and combined working hours and time. So rule number 5 is explain about we need to calculate comparing to both employees or both workers working time and the same time their working efficiency and working how much they are work rate. So we will see under this rule what are these there. So this is the condition for rule number 5 when we are comparing two workers rate. So here a person A is n time as a good workman as another person B, then the both are complete by the time A divided by equal to 1 divided by n, and after any time A's work divided by B's work equal to 10. This is the rule, fifth rule for calculating this time and work. Sixth one is chain rule. So these are not complicated one, just we have to know what are the basic rules when we are calculating like this kind of work related, like time related, connecting for both persons, both A and B are working together for one entire day. So we need to calculate the which one is more comfortable or good workman, this kind of question. So we need to know what are the basic rule or common rule for following for easy way to calculating this kind of problems. So not that much complicated one, simple way to we have to get the answers. And sixth one is chain rule. In this chain rule a symbol like equation is there. Man 1 into day 1 into work rate 1. That means one person and 1 day work and work rate, that means the efficiency of work they are doing, divided by amount of work done equal to another person. We are talking man 2 into day 2 into work rate 2 divided by amount of work done. This is a sixth chain rule of calculating work and time. So here's nothing, took one person's and it's equal to second person, like how we are calculating. When we have to took man 1 and day 1 and work right divided by amount of work done, and we have to equal to the second one person like man 2 into day 2 and working right divided by work done by 2. So this is a basic 6 rules we have to follow or we have to analyze, and we need to know about when we are going to attend the competitive examination for this kind of work and time related problems. So we are discuss about the basic 6 rules of rule or concept of work and time related problems. We will see the last concept or last rule of that work and time is chain rule. So we will see the theoretical part of chain rule. In this theoretical part we will see the relationship between men and work. More men can do more work. It's a basic simple concept relationship in this chain rule. In the theoretical aspects of chain rule, the first relationship between men and work, we can easily say that more men can do more work. Then second one is relationship between work and time. This one is our topic, work and time. Here also more work takes more time. In this one, relationship between work and time, here also more time take more time, more works take more time. Here also less work take less time. And before that, here also men and work, that means low men will can do low works. That means less men can do less work. In the same case, more men can do more work. In here, relationship between work and time, here more work take more time, less work take less time. And the third one is relationship between men and time. So you can say that like more men can do in less time. Here some contradiction is there. Less man can do in more time. So how it's working? Relationship between men and time. Here more men can do in less time. A number of people are there, so time required or needed is very less. But in the case of less man, that means number of people, number of employees is very less, so they can do in more time. They need a more time to complete that particular work. So this is the chain rule theoretical relationship between like men and work and time, same as men and time. This is a basic logical concept we need to know before we are attending in this kind of problems, because in a simple logical way to analyze how to solve these kind of problems. So this is a basic concept we need to know about that. So here we will see one question related to work and time. Question. So this will be the question. So kindly connect the rules of this work and time. So question clearly say that two persons are working. Dhoni and Reina can do a work in 12 days. Here mentioned that 12 days, and Reina alone can do it in 28 days. So one person, who is that? Reina alone can do it in 28 days. Here also mentioned in how many days can Dhoni alone finish the work. So here, so we need to put in the equation like total time 12 days. They both took 12 days to complete their work, so it took 12 days. And n, how many days total? Reina can finish their work in 28 days. N number of days, 28. So required time equal to T and N equal to N minus T. Here 28 days into 12 divided by 28 minus 12. So this 28 total Reina's alone date, the total date divided by 28 minus 12 days. So we will get 21 days. So Dhoni, how many days here? How many days can Dhoni alone can finish the work is 21 days. So we will get 21 days required to finish Dhoni alone to the work.